Programming and algorithms. A quick review. First off, algorithms. An algorithm is a finite set of instructions that solves a problem. In the developmental process of programming, we design code using sequencing, selection, and iteration. All three must be used when completing your create performance task. Sequencing. Lines of code will execute in the order they are listed, meaning line 1 executes, then line 2, etc., without repeated or skipping. One must be thoughtful when coding so the logic of an algorithm is ordered and completed to perform the set of rules intended to solve a problem. A type of multiple choice question that you will encounter using a temporary holder variable. This type of question involves the use of variables, and the sequence of those lines of code matters. The next two examples work for swapping values. Here we have line 1, even gets 2, odd gets 5. Temp gets what's in even. So if we think about drawing some buckets here, we have even, we have odd, and we have temp. We're going to do even, odd, and temp. So even gets the value of 2, odd gets the value of 5. Temp receives whatever is an even, so it gets 2. Then even takes whatever was in odd, so it gets 5, and then odd takes what's in temp, so it gets 2. Thus, you've effectively swapped the even and the odd. The order matters in some of the lines of code. Lines 1 and 2 could be interchanged, but line 3 must come before lines 4 and 5 to establish a successful swap. Even is placed into temp and must be reassigned before odd so that the value 5 is not lost. Let's look at this second one. Let's do a little bit of erasing here. Okay. Here we have even gets 2, odd gets 5. Temp gets odd, which is 5. Odd gets even, which is 2. And then even gets what's in temp, which is 5. In this example, again, lines 1 and 2 could be interchanged. However, line 3 must come before lines 4 and 5. Odd is placed into a temp and must be reassigned before even, so the value of 2 in this case is not lost. Your turn. Determine the missing code. Pause the video and try these. Okay, you're back. A programmer is trying to write a sequential algorithm to calculate the area of a triangle. What is the missing code needed to complete this program? You get the height, you get the base, area, we have missing code, and display area. Notice, it could be this or this. Height times base, not height plus base, and not 0.05. That's not 1/2. But over here, we have a programmer is trying to write a sequential algorithm to calculate the slope of a line between 2 points. Given the ordered pairs, what is the missing code? Well, remember, it's the difference in the y's over the difference in the x's. The order matters. So here you have y1 minus y2 over x1 minus x2, but notice that without the parentheses, you're going to divide the y2 by the y1. You don't want to do that, so you need parentheses. Here, y2 over y1 minus y1 over x2 minus x1, that works. x1 minus x2 over y1 minus y2, that's wrong. That's run over rise. And then here, we just switch it around and we put the first point first. Selection. If statements are implemented in algorithms to determine a path to the solution when a decision is needed. A Boolean conditional statement is used to determine your true or false outcome. If the condition statement is true, it will execute the outcome. Otherwise, the next line of code outside the if statement will carry out. Below is an example of an AP block form. If birth year greater than 2000, display underage. An if statement checks the numeric variable birth year. If it's greater than 2000, the statement is true and outputs the string underage. If it's false, then the next executable line after this block would run. Here's another example in AP text form. Let's say we have an algorithm that calculates wages and keeps a running total. If the hours worked is 40 or more, you earn $20, and this is calculated and accumulated with the variable wages. So if hours greater than or equal to 40, wage becomes wage plus 20 times hours. An if statement checks the numeric variable hours. If it is greater than or equal to 40, if true, wage is incremented by the sum of itself and the product of 20 and hours, and that would be 20 times hours. If there's a need for an alternative outcome when the Boolean statement is false, using an else statement will be used to provide that alternative outcome. If hours greater than or equal to 40, you do wage is set to wage plus 20 times the hours. Else, wage is set to wage plus 18 times the hours. Adding the else provides the alternate outcome when the Boolean condition is false. The variable wage is incremented by the sum of itself and the product of 18 and hours. Your turn. Pause the video. If the input value for hours is 35, what is the outcome? You're back. Well, 35 greater than or equal to 40 is false. So instead of executing the if code, it's going to execute the else code. Wage is currently 0 plus 18 times 35. Therefore, you will display 630, which is the product of 18 and 35. You will also experience questions that have nested conditional statements. For example, if age greater than 60, display senior discount, else. If age greater than or equal to 18, display regular price, else. If age greater than 5, display child price, else. Display free. Your turn. Use the values below to test different selections for this block of code. Try each one of these, fill in the table, and then start the video again to see how you did. Did you get senior discount? If age is 60, you're not greater than 60, so you're going to come down here, but you are greater than 18, so you'll do the regular price. What if you're 18? Well, that's going to be the regular price again, because 18 is equal to 18. What if you're 10? Well, you're not greater than or equal to 18, so you're going to drop down to the else. You are older than 5, so you're going to get child price. And then you'll get free if you're under 5. Your turn. A certain board game has rules to move your game piece depending on the roll of one red die and one blue die. Each have 6 sides. What different combination of rolls will result in you losing your turn? Here's the code. Look it over, pause the video, and decide. Both must be true. If red die plus blue die greater than or equal to 8 and red die equals 4 or blue die equals 4, lose a turn. Your game piece doesn't move. So the sum is greater than or equal to 8 and one of them must be 4. So that means you get 4, 4, 4, 5, or 5, 4. Okay? Iteration, often in coding. As a matter of fact, I'm going to stop here so that you can watch the first half of this video and then we'll do the second half.